This video is about parallel and perpendicular lines and what they mean, the concept, and how to find whether they're parallel or perpendicular and to prove that. We also will look at when they intersect, also how to obtain equations for parallel and perpendicular lines. So this will be a couple of, at least 2, maybe 3 videos. So 3.3, we are on page 40 of your workbook. Parallel and perpendicular lines. Find the slope of each line and compare. What is interesting about the slopes? So if we look at the slopes here, we'll look at this line 1 is in blue there, and we're going to find a couple of corners on it, like, okay, of the grid, just so it's easier to tell. So these 2 points here, so we have negative 0, negative 1. Let's get in the habit of labeling. And then this one is 3, negative 3. And we can look on the graph and we can find our slope triangle that we go actually down 2 units. So that's a -2. And then we go right 3 units. So that's a +3. So our slope for line 1, I'm going to label M sub 1, is -2/3. We can double check that. We could find the difference of our points if we wanted to, just real quick. -3 minus -1. That gives you good practice for that if you struggle with that skill. And then this would be like a adding. Okay, so we'd have -2/3. And that does match up so that we know we're all on the same page. Now, the next one over here, we have a couple points. I'm not going to go through that whole process again. We're just going to eyeball for line 2. We go down 2. Again, that's a -2. And right 3. So we have -2/3. And again, we usually like to center it. We could also write it like this, 2 over -3 if we needed to, because we can go up to left 3 would be the same. So that is what happens with our 2 slopes there. So we can see that M sub 1 equals M sub 2. So that means that they're parallel. They'll never touch because they're not going to slant. So never, ever, ever will they touch. So I'm going to put these 3 dots to say therefore parallel lines. Okay. So here's a more formal definition in your workbook. If you are just copying in a notebook, you might want to write that down. Let M sub 1 and M sub 2 be slopes for lines L sub 1 and L sub 2 respectively. That means these lines are parallel to each other if they have the same slope. But they have different y-intercepts. So that was another thing too. They weren't exactly the same lines. Sometimes you'll end up seeing that lines will do what's called coincide when we look at systems of linear equations, that when we graph, we'll have one lay right on top of the other. Okay, so determine whether the lines are parallel, why or why not. So I am going to do A with you as an example, and then I'll leave B you can do as a classwork, so to speak, or try it on your own. But we don't want to just take a guess like, oh yeah, I think they're parallel. We have to prove it, and so we have to find out what their slopes are. So the first step is to figure out slope for each line. Okay, and I'll do that with you, and then we're going to compare. Then compare. All right, so if I have line 1, I'm going to that in the pink here. We're going to bring that down. We can find slope by having 2 points. We can look at a graph. We can actually rearrange into a slope intercept form. That's probably the easiest thing for us to do here. However, you could graph it and look at the graph if you wanted to. That sometimes is a good checking mechanism. So here we don't want the negative 2x on that side, so we want to subtract it from both sides. Just solving out a literal equation. We could think of it as moving it over and changing its sign. Be careful of your signs on these. If you are always getting a wrong sign, then you're not carrying a negative correctly or doing something with that. Oops, I put B instead of 8. And now we want to divide both sides by 3. Okay, and we actually need to split this apart so we can determine exactly what the slope is. So we have 2/3 x plus 8/3. We want to write it that way. And then the slope for line 1, this is line 1. My slope is 2/3. So m sub 1 equals 2/3. Okay. Now we're going to do the same thing for line 2, and we have this one here. Let's draw a little arrow. So we have negative 6y equals negative 4x plus 12. So be careful again, watch for this. Make sure you don't lose that negative. We're just subtracting 4x from both sides. We can't combine it, so I just write it there. Then the next step, we are going to divide everything by negative 6. So we'd have y equals negative 4 over negative 6x, or negative 4, 6. They're both negative, times x. Careful how you write that, plus 2 over negative 6. Now I'm going to simplify this to be y equals 2/3. So I made it positive and I reduced, plus a minus 1/3. Oops, I just noticed my mistake when I wrote this down from up here. Hopefully you caught that. I should have had a 12 there, so I'm just going to fix that. 12, and so I should have minus 3. And what my big takeaway is for line 2, my slope 2 for line 2 is 2/3. So we can see it right here. So these are in fact equivalent. Therefore lines are parallel. And you could just write it as L sub 1 is parallel to L sub 2. Okay, so that would be your answer on that one. So try B. Hopefully you can have a little more room there, but see what happens with the slopes. Just rearrange them into slope intercept form. So pause the video. Okay, so here's the result for that. We have line 1 is equal to y equals negative 3x plus 9, so our slope is negative 3. Line 2 ends up being y equals negative 2x minus a half, so I have slope of negative 2, so those are not equal, so therefore the lines are not parallel to one another. So that's it for this video. Thank you for watching. There'll be the part on perpendicular lines and then mixing everything together.